and let's talk about how you can solve it. There's one way we can do this. There's many ways, I guess, you were able to do it. So I guess I'm going to show you one of them. I should also say I'm terrible at Excel, so I don't blame you if you didn't, do it in like 10 minutes. I think this isn't too easy, especially with trying to remove duplicates and incomplete observations. It's all doable, but I think what I'm going to show you now is randomization. And at the end, I'm going to show you my more preferred way, which is data. That takes care of a lot of the things that I think some of you ran into problems with. Okay, so what I would recommend is add a new column and call that column, for instance, a random number. And you start at 1, and it goes all the way down to the number of observations you have. Obviously, at that point, it's not a random number yet, but it has one unique number for every observation. And again, we're assuming now that you don't have duplicates in there, because otherwise you end up having, for instance, you might have the same person you're sending an email to or a mailer twice in there, and that would kind of suck if they end up being in a control entity group. So these kinds of things you want to take care of before you do this. So once you have done that, go online to the random.org/lists. And I recommend doing it this way instead of using Excel's own randomizer, because that way you can then reproduce the kind of results you have achieved. And Excel also has this very strange behavior that whenever you make any change in your document, it will generate new random numbers. I don't know why that is, but it gets annoying because that obviously confuses your whole randomization process again.
And there's no way to stabilize that?
I know you can overwrite it actually. You could copy and paste the list after you've generated it once and then fill in as values, not as functions. Yeah. But I just think there's a better way of doing this, which is this one. So after you've generated, so again, you generate this column, then you go over to the list randomizer online, and you click on randomizing it, right? You copy and paste that list in, you come out with something like this, and then you copy and paste that list back into Excel. And then all you need to do is use the filter method, which is up here. I think most of you have used it before. And then you sort it ascending or descending. And that's basically it. Assuming that the randomizer you used, which is random.org, in this case, if it's really truly random, then you're going to have now a randomized list. Now, turns out random.org is very proud of their randomization algorithms, so I think it's a pretty good bet here. But that's exactly what you want to do. This is something that is truly randomized now. You go back, you sort your number of people by that new random column, and then you just split, in this case, your sample in half. The first half is a control group, the second half is treatment. That's it. So that's the simplest way I can think of using Excel to randomize, but I'm happy afterwards to chat a bit more. If you have any questions now, otherwise I'm going to move on.
Sorry, I missed the first point about cleaning the data set in Excel.
Sure.
How do you do it?
So I think it's difficult. I think you would have to, some people will have a good method. I think there are ways to actually find duplicates. A very annoying way that I think I've found to work is you sort them by the observation number and you go through and then look at where they match. I think it's a very manual and
inefficient way. So it's the only way, because in state I think it's much easier.
There is, yeah.
There's a function apparently. Okay.
There's a dedupe function underneath the data tab.
There you go. Oh. And I'll show you now why I don't usually have to worry about this so much, because I use data, and that's the code for data. It's going to be available afterwards, so you're welcome to use it. It's just a very simple randomizer, and we're going to have some more complicated cases later. But here you can clean the data in about 5 lines. In this case, the way I've handled it is I've dropped observations that missed something or that had some duplicate record, of the zip code, the custom ID. In general, it's not easy to decide what protocol you want to use there, because maybe there's something special about the people who are duplicates in your data set. For instance, you might be extremely motivated and be on your mailing list 5 times, and you're kicking them out. So it really depends on your situation what to do with duplicates, but a conservative way of dealing with them is not to include them. But always, very important, always protocoling what you're doing. Like write down why you're removing them or where you've removed them. Just a quick note here. We've used this random generator, which is good. It's also good because now other people can see how you've done it and they can go back and do it as well. These pages you can save, they have a timestamp, so it's good for replication. Another thing is you won't always have data available, right? Think of cases where you don't actually have a whole list of customers available. There are situations like you organize a workshop and people walk into a room and you would like to randomize them, but you don't exactly know how many people are going to come today. So in that case, what you need to do is think of a way to randomize people like you as you come in. And I don't know if you, when you came in, if you've noticed how it worked. What method did I use? So you came in, you were told whether to go left and right. What do you think happened?
Like quasi-randomized?
It wasn't quasi-randomized, no.
You were blind to it.
I was blind to the moment it was randomized. So I actually did generate the random, well, I'm giving it away basically. I generated a random list. So what I did is basically, before coming in here, I used that list that I just talked about. I just put in half of them zeros, half of the other, it's right over there. It's half of them are zeros, the other half are ones. Zero meant going left, ones was meant going right. Then I randomized that list, printed it out, brought it in here, gave it to Laura and asked her to do me a favor, which she did. And then as you came in, she read out, is it a zero, then you turn left, and is it a one, you turn right. So this is really important, even though it seems kind of stupid. I could have just like done all sorts of other things. Like in my head spontaneously said, oh yeah, the random number is now go left. But the problem is humans are terrible at generating random numbers, and I can tell you why. If you look at my list, that's what it looks like. And it turns out there's a lot of repetition. And when you ask people, that doesn't seem random to most of us. But it turns out it is. I clicked the button exactly once, that's what came out, so I printed it, and that's how you get randomized, which is kind of interesting because, you know, if we had fewer people show up today, like say very few people and only 5 showed up, you will have 4 on one side and 1 on the other. As soon as you have more people, you can see that it works out just fine, which is why in the long run, randomization is really good for what you want to do. You don't have to worry about like balancing it out. In the long run, it's going to work out because of this law of large numbers. Sorry, there was a question, I think, on this side. No? Okay. So there's a question, though. What do you notice? Well, I guess I gave away that there's the strings. But what's a potential problem with this kind of situation?
You just mentioned one.
Yeah.
With a small sample size.
Yeah, I think that's right. Yeah. What would you do if you had a small sample and you ended up having 2 more people on one half? So let's say over here. Right? In that case, you have only 3 people in the treatment and the rest in control. Would you put people into the treatment group again?
You could re-randomize.
Yeah, that's one idea, yeah. What would you think would be the advantage or disadvantage?
I mean, you lose a little bit of integrity, I guess. Although, I mean, it seems like you would, because if you just randomize and then you decide to stay with one that you happen to like,
yeah,
it's still actually random, but it doesn't seem random.
Yeah. I think you gave a good argument, and then you gave a very good counter-argument for it as well, which is you should normally only randomize once for exactly that reason. You don't want to catch yourself doing the following, which is you randomize to this. You're like, that looks pretty good, but you know there's a bit of imbalance. I'll randomize it again. Now it would be good, but you're like, you know what? That one person should really be in treatment. So you keep randomizing like that. And people don't do this on purpose. It's not like we sit down and consciously come up with this kind of concept, because we know it's wrong. But subconsciously, these kinds of biases creep in. And we talked about biases in the last session, and Francesca talked about them too. So be aware, we're all susceptible to that. So at the end of the day, what I would recommend is, this happens, it's not ideal. You have to kind of stick with it. If you want to be, like you say, very ethical and honest about it, I think I would always recommend doing that. It's a better way of trying to make sure you get your data. But another problem you should always keep in mind, if you have only 5 to 10 people in here, you should probably think about if this is the right number to run the experiment with. And probably the answer is no, because what we're going to talk about in another session, power calculations will tell you you will just have not a big enough sample. So that's one problem. Okay, so I told you about Stata, and I've also wanted to mention, which is why I put it up there so I don't forget it, I'm going to talk mostly about 2 conditions at a time, but all of these concepts are pretty easily expandable to more than 2 conditions. Again, there are boundary conditions, and most often they tend to be sample size and how many people you have in your experiments. You don't want to go with too many conditions, but in theory, the same concept we just applied can apply to more than 2 conditions as well. Okay, before we move on, any more questions on this? All right, cool. So then I guess you guys are ready for more randomization. And this time, I'd like you guys to be in groups of, yeah, let's do 2 again. I think that worked out quite well. In that case, at this time I want you to think about the following situation. So say you're in a school, actually you're in a school district, and you have this task that it will be important that in most of these schools, 5 in those cases, I guess I chose 5 here, you want to maximize the number of people, and students in that particular case, who get a flu shot in November. So you know it's coming up, you know what it is, it's a flu shot, you know the 5 schools you're going to be working with, and your goal is to maximize increasing flu shots in that school to avoid that, it spreads across the school, so you think there's a public good. All of that settled. We're not even going to talk about exactly the intervention you're going to use. What I would like you to focus on now is how will you randomize into 2 groups, a control and a treatment. The exact detail of what, say for instance, a letter contains isn't as important as the question is, are you going to send a letter? Are you going to hand out an info slip, like a little sheet in the school that has that same information? Or are you going to use a centralized morning announcement in school? So it's not so important what you're going to say at this point. We're going to come to that again in a future session, like how to come up with really good interventions. Now I'd like you guys to think about what's a really good way of randomizing in this situation. Any questions before we go going into the small groups?
Why 2 groups if there are 3 options?
Okay, yeah, so I should explain that. So 2 groups is what you want to split the population of students at the end of the day, right? You want to have a control group and a treatment group. And I want you to think about what the treatment group looks like. So the control group gets nothing by default. They will not get any information. I would like you to think of one of those 3 being the treatment. Does that make sense? So you're now picking which of those 3 you're choosing to be your treatment. That's one of the groups. The other group is just a control group.
Okay, so we are also thinking about which one of the options we are choosing.
That's the main task, yes.
Okay.
That's right. But I don't want you to focus on, like, are you going to say dear parent or dear Johnny and Susan? That's not so important right now. So it's not the content, the behavioral insight we're thinking about now. We're now talking about which of those 3 channels you want to use to randomize it. Obviously, at that point, it's not a random number yet, but it has one unique number for every observation. And again, we're assuming now that you don't have duplicates in there, because otherwise you end up having, for instance, you might have the same person you're sending an email to or a mailer twice in there, and that would kind of suck if they end up being in the control and the treatment group. So these kinds of things you want to take care of before you do this. So once you have done that, it's all doable, but I think what I'm going to show you now is randomization, and at the end I'm going to show you my more preferred way, which is data. That takes care of a lot of the things that I think some of you ran into problems with. Okay, so what I would recommend is add a new column and call that column, for instance, a random number, and you start at 1, and it goes all the way down to the number of observations you have. And let's talk about how you can solve it. There's one way we can do this. There's many ways, I guess, you were able to do it. So I guess I'm going to show you one of them. I should also say I'm terrible at Excel, so I don't blame you if you didn't do it in like 10 minutes. I think this isn't too easy, especially with trying to remove duplicates and incomplete observations. Go online to the random.org/lists, and I recommend doing it this way instead of using Excel's own randomizer, because that way you can then reproduce the kind of results you've achieved. And Excel also has this very strange behavior that whenever you make any change in your document, it will generate new random numbers. I don't know why that is, but it gets annoying because that obviously confuses your whole randomization process again.
And there's no way to stabilize that?
I know you can overwrite it actually. You could copy and paste the list after you've generated it once and then fill in as values, not as functions. Yeah. But I just think there's a better way of doing this, which is this one. So after you've generated, so again, you generate this column, then you go over to the list randomizer online, and you